Hello, this is question 2 of homework 11, and what we should do is find whether the function is can be represented of a process by setting v equals tau, or a spectral density function by setting v equals omega, or both. So first one, we can get the fv equals e minus v. So from this, we know that it is a even function, and the Fourier transform of this is equal to 2 alpha over alpha square plus omega square. So this is non-negative. So because it is even and its Fourier transform is non-negative, and so we know that it can be represented an autocorrelation function. So it can be an R tau. And second, whether it can be a spectral density function. So because this function is non-negative, it is always larger than 0, so it can be a spectral density function. And the second one, so same, we get Fv equals sine square v over v square. So first, we want to find it is also even. And when we transform to the Fourier transform form, it can be a function like this. It's from there to there. It is we can draw it like this. So it is also non-negative when it after Fourier transform. So it can be an autocorrelation function. So it can be read like that at all. And so we know that this function is also non-negative. It is always larger than or equal to 0. So it can be a spectral density function by setting v equals to omega. And we can look at C. C is Fv equals 0 when v larger than alpha, and equals 1 when v less than alpha. So this function is a picture like this. When it is between alpha and minus alpha, it is equal to 1, and others, it is equal to 0. So we know that this function is even, but the Fourier transform of this is 2 sine alpha omega over omega. So we know that it is not a non-negative function because sine alpha omega can be negative or positive. So because its Fourier transform is not a non-negative function, so we know that it cannot be an at all. And we look at the function itself, because it is always non-negative, so it can be a spectral density function.